Thank you, Ina, and good afternoon, everybody. Happy to see a lot of interested faces here that want to learn a bit about Styrenics, which is a good cause because it's a very interesting group of products when it comes to circular economy, when it comes to recyclability, because we truly believe that Styrenics are made for recycling. And well, I want to use that opportunity to show you why we believe so and what we have in store here now in the presentation, and also at a booth in Hall 6, where you're obviously also invited to visit us. Is this supposed to work? Yep. Wow. Good, great. About INEOS Styrolution, we're part of the INEOS group that probably most of you know, and we're the part of INEOS group that is working on Styrenics. So all plastics materials that are based on styrene as a raw material. We consider ourselves a global leader in Styrenics, and as you can see, it's a fairly large company with 3,500 people working there and a turnover of a bit over 5 billion euros per year. So quite something, and that's why we have quite some activities also ongoing into that topic that everybody here at the K Fair is very interested in, which is the circular economy. And I don't want to spend too much time on introducing the company because, you've seen thousands of those slides before. Let's go straight to the topic and have a look at the circular economy and what we as a Styrenics producer believe we can bring to the table here. You've probably seen 1,000 of those circles before, and in essence, they are all comparable in the sense of that, you start somewhere with raw materials and then you produce products out of it that are used, and after use, that's where the issue starts. Basically, after a product is used, it becomes waste, and that's a waste of resources, because we believe that these products are valuable resources, that there's valuable still raw materials even in the waste, and that's what we want to work on. We want to basically go back from waste into products. I will now show you basically two approaches that we have and that we are working on together with partners and alone in R&D in developing. The first one would be that we do mechanical recycling of the products. That's a technology that most of you know, but with our knowledge on products, with our knowledge on modification of products, we believe that we can bring mechanical recycling onto a whole new level, that we can produce mechanical recycled crates that are, as far as the properties are concerned, pretty much on par with a non-recycled material. And I think that's quite a breakthrough that we achieved there. And the other topic that I will talk you through in the upcoming minutes is that we look at chemical recycling, in particular at depolymerization, which is one kind of chemical recycling that happens basically at lower temperatures than others, and that goes back straight to the monomer, which is a fairly short circle that we can build here. Very interesting, and can be done with products like polystyrene, for example. So, that being said, we are also looking into bioattributed feedstock. I will not touch it now. If you want to know more about this, you're very welcome at our booth. We can have a discussion there. I'm going to be there for the next couple of days as well. But since we want to focus on recycling in this next 15-20 minutes, I will skip this topic if you allow. Now, let's go a bit more structured to the approach. What you see here is a typical value chain, if you will, that starts somewhere with raw materials. Then this is basically our world. We produce plastics resin out of it. We typically produce Styrenics resin out of it. Now, from here, our customers take over, and it goes down all the chain to the consumer, and that's up at waste. The challenge now is, how do we get back from waste to plastics production? That's basically what we're working on, what we're looking on. And I branded that presentation Styrenics made for recycling for a reason. And the reason is that Styrenics offer a pretty broad array of technologies, of methods that you can apply in order to get back from waste to plastics productions. Probably more than many other materials. And that's why we believe they're very well suited for circularity and further circular economy. After waste, what typically happens is that waste is collected and sorted, and I've seen there's some exhibits also from sorters here, like Alba, like Cesotec, and so on. So if you're interested in that technology, there's quite some stuff that you can see in this pavilion here. Very interesting what these companies bring to the table. And that's a pretty mighty technology already, because sorting is needed downstream when it comes to many of those options, because only if you have a fairly well-sorted waste, some of the technologies that I'm going to show you are working well. So that's kind of a precondition for some things. Now, what everybody would consider recycling, that's what a consumer knows and what a consumer understands, is mechanical recycling. So basically you shred waste into smaller pieces and make something out of it. But there's more. There's also other options that we can apply here. One is dissolution, and I've seen that Polystyrene, for example, is exhibiting here in this pavilion, which is one of those companies that is fairly active in dissolution of polystyrene. So basically you apply solvent in order to get back to a cleaner, smaller part of, well, styrenics, if you will. So you apply solvent as a kind of cleaning agent, very simplified now, to polystyrene, and get back to a clean polystyrene. What we are concentrating on as well, besides the typical path of, well, chemical recycling, gasification, could also be large-scale pyrolysis, that goes back to the raw materials, is that we concentrate on, well, a solution that's in the middle that you can do with polystyrene, and that's a key advantage of this product, that we call depolymerization, where basically, and I'll go into a bit more detail in a minute, you can break down the polymer back to the monomer. And that is a very, very interesting solution, because that's a very simple way to get back to very clean products, because you really go back to the monomer, but you don't have to go all the way, and you don't have to go into real big scale, very complicated installations here. So that was a bit of the structural part of it. Now let's go a bit down into more detail here and leave the structures for a minute. Starting with mechanical recycling, because now I want to show you what in detail we are offering here at K-Fair and what we brought with us to Düsseldorf to present during the next couple of days, kicking off today. We believe that, or at least we try to build the best recycled ABS in the world. That's a fairly bold statement, but that's what we try to do, that we come up with a mechanical recycling ABS that basically has a performance on par with non-recycled material. That's our target, that's our aim. That's basically the vision that we created on ABS, because we don't want to have any more downcycling. That's what you typically see when you hear mechanical recycling, that over time the quality of the products goes down. And we believe that with our science, with our knowledge, with our experience as a styrenics maker, with all the modifiers that we can add into this, we can come up with products that are basically on par with products that are not recycled. And I brought a couple of exhibits here. We have way more in Hall 6. So if you look at this product, for example, that's a part of a washing machine, a top loader panel. And basically, if you look at the mechanical properties of it, if you look at the surface quality of it, you wouldn't recognize that this is made of a recycled material. And that's something we're very proud of, that we have been developing this over the past couple of weeks. A material that basically can contain up to 70% of post-consumer recycled material. We have products available of 50, 70%. That have the same or comparable properties to those products that are not recycled. So you get high gloss surfaces, you get high quality colors. At the end of the day, it's a drop-in solution for a producer, because it behaves like any other product when you work with it. And if you look at the properties of it, now that's a bit more detailed here, you would see that this is one of our standard high-quality grades, Terlawan GP22, with no vesicle share. If you look at this and compare the products that we created with a 50 or 70% of vesicle share, basically they're on par, they're comparable. And that is quite an achievement, and we're quite proud of this. And we had some very good feedback already in the first hours of this fair, and we're happy to, well, see what you can do within the next couple of days. Moving from mechanical recycling to chemical recycling, in that particular case, looking at depolymerization, what we try to do is to basically take the single out of single use. So we want to create also chemical recycled styrene with identical performance. And that is, or Styrenics with identical performance. And that is quite a challenge, especially when it comes to something like a yogurt pot. That's one of the most prominent applications of polystyrene, yogurt pots. But, well, it's a food contact application. And most of you know that, well, recycling and then going into food contact, that is one of the biggest challenges out there, to be honest, in the circular economy. And, well, I see a lot of nodding heads here, so I see that I'm talking to experts here. This is quite a challenge that we want to address. And we believe that we have quite some interesting approaches here by the means of depolymerization. And the product, or the process that we are looking at, is basically going from yogurt cup to yogurt cup. So we take a yogurt cup like this one up here, and basically go into sorted polystyrene flakes that we then depolymerize. What does depolymerization mean? Basically, we apply heat to it, and the heat breaks down the polymer back into monomers. So in our case, into styrene. And polystyrene is very well suited for this. Why? Well, on the one hand, because, well, you only have one monomer that you go to, that makes it very simple. Then this is a, styrene is a fluid polymer, so you can, well, in this step here, where are we? Clean it down and basically remove in distillation all unnecessary parts from it very easily. And that would look a bit like this. So if you do the depolymerization, what you get out of it is something that looks a bit like this. So that would be a styrene oil. So that's dark because there's quite some stuff in there, but it has a fairly high content already of styrene. So there's a lot of power in here, and that is a lot of value in here. So it used to be waste. We depolymerize it, and we get a very valuable liquid. And that's what we want to achieve. Take this valuable liquid, process it by basically distill it, and get something out of it that looks like this. So that's the look of styrene. So we go from the styrene oil, distill it into styrene. And now with this product, basically we can go all the way back into the production processes that we know. We have the same, well, quality requirements that we can meet. We have the same production technology that we can meet. So basically, this allows us to produce grades that are also, well, food contact compliant based on styrene. And that's what we've been working on for the past couple of months. And we're very happy to, well, show for the first time at this fair some examples of this. These are, well, yogurt pots that are made out of depolymerized polystyrene. So this is probably the first time that, well, this has ever been shown. We did the first proof of concept in April. Many of you have probably read it, where we were introducing that technology. And now with our cooperation partner, we have, well, basically those exhibits here that show that it can be done. And that's basically the circle that we did here. So we took those flakes, depolymerized it, then we distilled the oil, and we basically went back from styrene to polystyrene, extruded some sheets out of it, and those came back into those yogurt pots that many of you know. I don't know if those people from outside of Europe are pretty aware of those, but that's a pretty successful product of one of the biggest dairy producers in Europe, of the Unternehmensgruppe Müller. So that's basically what we're working on. Right now we are, well, on a fairly small scale, so we are trying to move up from lab scale into production over the next few years. We hope that we can introduce products to the market as early as 2021. That's what we're working on, because we truly believe that this is going to be the future, and that this is truly proof of our claim that Styrenics are made for recycling. So that's what I wanted to show you today. again, you're happy to visit us at Hall 6, D28, and if we have time, I'm pretty sure that you will also have the opportunity now to ask a couple of questions. Right, Dina?